So I'll wait. We're running a little bit behind, but I'll wait one more minute just to make sure everyone's getting set up. Log into Blackboard. If for some reason you didn't do the attendance last week, get that taken care of now. Okay. You only had to do that the first class. Remember, I don't do regular attendance. That's just like an IRSC requirement. It's actually, I think, like more like a federal requirement. It's basically if you don't show up to the within the first week of class, you get dropped from the course. So get that taken care of. Again, if you took care of that last class, you don't have to worry about it. It was just like a one-time thing. And if you weren't here last class for any reason, the lecture is posted. But for the most part, we just kind of talked about the syllabus and stuff like that. We did a little bit of actual coursework, but today is going to be the first day that we really start with coursework. Now, normally with this class, just to let you know, I'll very frequently, so normally we meet 2.5 hours, and the course is at a pretty relaxed pace. Because it's hybrid now, you'll be expected to do a lot more at home, versus like normally we can get most of the stuff done in class, and then if you just have any leftover work, that becomes your homework. But because we have reduced lecture time, I won't be able to say things multiple times. So when this class meets twice a week, a lot of times I have time at the beginning of the class to review what we did the last week and have some more discussion, but now we're just going to have to get right into it. So what that means is if for some reason you missed class or you didn't understand the previous week's material, you'll have to go back and watch the recorded lecture. Okay, everyone's clear on that? So if you miss a class, say you missed next week, don't just show up to class the following week without having watched the lecture because you'll probably be lost. Okay? So keep that in mind. Okay, is everyone set up?
Yep.
Okay. So most of the classes I do aren't very PowerPoint based. This one kind of leans a little bit more toward PowerPoint, but what I like to do at the beginning of the semester is just some practical skills. And one of them is just building a computer, because many times in these books, what they'll do, sorry, I'm just checking this every once in a while to make sure the stream hasn't dropped. What they'll do is they'll talk about parts very generically. Oh, a CPU, a motherboard. They won't really get into the details of what a motherboard looks like in 2020, or what a CPU looks like in 2020, or who the main manufacturers are in 2020. Okay, a lot of times they talk about things very generically. And what I like to do is many times talk about things in the concrete, because you're not going to get to your first job and, be able to replace a motherboard if you don't know anything about the specifics of motherboards. Now, you will take a class. I'm pretty sure it's required for the degree on A+. Has anybody taken the A+ class yet? Sometimes a couple people take things out of order. So you will take a class that's much more dedicated to the computer hardware. So if you don't understand things completely after this, don't worry, because you will take a much more in-depth class. But one of the things I like to do is just make sure everyone's getting the getting some practical skills, but it doesn't necessarily have to be complete. This is what they call a survey course. You learn a little bit about a lot of different subjects, and it kind of just goes over things surface level, and then as you go on in your coursework, you tend to take more specific classes. Okay. So one of the websites we talked about last week was Newegg. So everyone open up your browsers and go to Newegg. And as I mentioned, this site started off as a site which mostly dealt with computer hardware and components. Now they've expanded. Now they're more of a generic e-commerce site, but they still do have a focus on technology-related things. But every once in a while, you'll see random stuff like kitchen appliances and like even really random stuff. Like you might see like shoes, So But you can see here scrolling through, for the most part, they do tend to concentrate on computer equipment. Okay. Now, in the real world, you don't tend to, like, say, for example, if you're working for a company and you're managing 1,000 computers, you and the rest of your team. Now, in practice, let's say this classroom, for example, if you're working for IRSC and you needed to upgrade and replace all the computers in this classroom, you're not going to go and build these computers from scratch. It's very common to go to a company like HP or Dell because the margins are so thin on manufacturing PCs that you don't actually, in practice, tend to save that much money by building them yourself. For high-end PCs, it's a little bit different, but for your typical office PC, you don't tend to save a lot of money. They can, they build so many of these things that it's hard to build it much cheaper. You can get a little bit cheaper, but not a whole lot. So now in the real world, you're not going to, when somebody, a new employee arrives and they say, hey, I need a new computer, you're not going to go out and buy the individual parts. You're typically going to go to a site like a supplier like a Dell or HP or something. But I still like to go through that process to give you a sense of the actual companies making this stuff. So like on CPUs, who's making CPUs, what are the companies making motherboards, what are the companies that make RAM, and that gives you just kind of a good sense of what's going inside the computer. Okay. And to this day, I still build my own computers. It's just kind of nice to know what's inside. When you buy a computer from a Dell or HP, they use very generic parts. Usually they strike a deal with some company, and often it's like unlabeled, so you don't know where it came from. So it's kind of nice. There's little things that we'll talk about, like power supplies. A lot of times in HP and Dell, and I don't want to pick on those two, but they're, I think, two of the largest. They'll use whatever the cheapest power supply they can get a hold of. And there's been problems in the past with that, with things like capacitors and stuff like that. So it's kind of nice to know what goes in your computer. But in the real world, you're probably not going to do this. Okay. So everyone is able to get the new egg, correct? So let's start off. We talked about last week the basics of a computer. And so if I'm building a computer, the very first thing is I need something to do all those calculations. And what's the component, what's the thing that does all those calculations? It does addition, subtraction, it does all the actual calculations. The CPU, exactly. So we know we're going to need a CPU. Now by itself, the CPU only has a tiny, tiny bit of working, what we'll call memory. It has these things called registers. It actually has a few bytes of registers. I don't know that, like, if very many of you realize just how little storage is on the CPU. It's very, very little. And then they have other caches and stuff, but the actual register is only a few bytes. And so a few bytes isn't enough to work with. So if I have a large game that I want to play, the whole game can't just run on the CPU. So we have another thing that we call working memory. And then what's the name of the component? What's another name for your computer's memory? Starts with an R.
RAM.
Your computer's RAM. Okay, so we've got the very basic components. We have the thing that does the calculations. We have the thing that holds the data. Think about RAM like that it temporarily holds the data. Now, what happens to your computer's RAM when you shut off the computer? Does it stay around or does it go away? It goes away. And that's not terribly useful, because what if you have an important file that you're working on and you shut the computer down? It goes away. So what thing do we have that holds data long term? So exactly, a hard drive. So generically we call that storage. So the main three things that we need to start off with are we need to have a CPU, we need computer memory. Now the specific technology that satisfies that is called RAM, but generically we talk about memory because there's a lot of ways to satisfy memory. And then we need storage, and storage is typically going to be a hard drive or a solid state drive. And we'll talk about the difference between the two as the course goes on. Can everyone hear me in the back with the mask on and everything? Everyone's good? Okay. Now if I took those three components and I just placed them on the table, would I have a working computer? No. How do I connect all these things together to communicate? What's the device or the thing or the component that does that? The motherboard. So I get a motherboard, I put in a CPU, I put in the RAM, and I put in the storage, the hard drive, solid state drive, whatever. And let's forget some of the details for now, like sound cards and video cards and stuff like that. For typical office systems today, they actually just put them right on the motherboard. So they'll just solder a video card chip right on the motherboard, solder sound card chips. If you're doing more high-end stuff, you typically have a separate card. But let's talk about just a simple system for now. Okay, so we've got that. Now, if I were to take all that and then go on the motherboard and try to press there's not really a power button, but you can power it on from the motherboard. So let's pretend there's a button. If I have all those components plugged into the motherboard and press the button, would the computer turn on? Yes or no? No. What am I still missing? Power supply. Okay, so let's start off with that. Let's start off with those components and let's go through one at a time. So the first thing we talked about, so I'm under components, CPUs and processors, and we're just going to stick to desktop in this class. Server gets a little bit more, I don't want to say necessarily complicated, but if you were to go out to the tech news sites right now, most of the discussion and most of the information that you're going to find easily is going to be on desktop level stuff. The server is more like a very specialized community where they don't really tend to, they sort of talk within themselves a little bit more. Okay, so components, CPUs, desktop processors. So what are the two main companies making desktop processors?
Intel and AMD.
Exactly, Intel and AMD. And when you're creating a computer, that typically becomes the first choice. Why is that? Because I can't take, there's, as far as I know anyway, maybe there are like specialized, but for the most part, there's no such thing as a motherboard that works with AMD chips and Intel chips. Like I said, there might be an extreme case, but for the most part, I've never seen one anyway. I can't take just a motherboard. I can't pick the motherboard first and then plug either an Intel chip or an AMD chip. They're not really compatible. They have different what's called socket types. Now again, I'm very careful with what I say because after class somebody's going to email me and they're going to find some obscure motherboard. For the most part, for the 90% of cases, the CPU is the first thing that you pick because it sort of sets the stage for everything else. Okay, so what we'll do is we'll start off with just an Intel system, and then we'll go from there. So under manufacturer, let's go to Intel, and then the next one we'll go to AMD. Now their product lines are based on, and I think I mentioned this previously. So to take a step back, in the 90s, they had this thing called the megahertz wars. And if you're interested, it's called the megahertz myth. I've heard it called the megahertz wars. It was basically this competition between AMD and Intel, so you have this thing on your computer called the clock speed. Now the clock speed you can think of like the second hand on a clock. Okay, it ticks and it ticks and it ticks and it ticks. And so you can only execute one what's called CPU instruction for each one of those ticks. And so any logical person would assume that, okay, the faster those ticks, if I can do instead of 1 tick per second, if I can do 2 ticks per second, well, that computer can now run twice as fast, right? Because I'm ticking every half a second, I can do twice as many instructions. That held for a little while, but what companies started to do was they don't all use the exact same instructions. Sometimes they get a little bit tricky about how they do things. Sometimes they'll take one instruction and they'll break it up into multiple clock cycles, and they have all kinds of things. So what they were doing is they were ramping up their CPU clocks measured in either megahertz or gigahertz. And what they would do was then they would mess with their instructions. So it looked like you had this computer that was, say, 4 gigahertz, but it wasn't that efficient. So it had a very high clock speed, but it wasn't that efficient. And so there was this period of the 90s and early 2000s where it was very, very, very difficult to compare CPUs. even within Intel's own product line, you could have a computer, or a CPU, I should say, that one was, say, 3 gigahertz, one was 2 gigahertz, but somehow the 2 gigahertz computer was actually faster because it was more efficient. It was very, very confusing to consumers. They had other things like caches and so on. So what they did at some point was they said, this is getting too confusing. Let's simplify our product line. We're going to have what's called an i3. That's going to be the low end. i5, that would be the medium, and i7. Now, since then, they've also added the i9. They've complicated it a little bit more. But for the most part, they've simplified it. And the idea is that across the board, the i7 is going to be faster than the i5. Across the board, the i9 is going to be faster than the i7. They've simplified it a little bit. Okay. Over time, nothing stays simple. So what's happened is that they release what are called generations. Every year and a half to 2 years, they come out with a new CPU. And then it becomes, again, a little bit difficult to compare. So say, for example, I have a 9th generation i7, which is the fastest of the last generation. And then you might say, okay, is that faster than an i3 from this generation? And it becomes a little bit difficult to compare. We'll talk about ways to compare later. They're called benchmarks. But for now, we're going to keep life simple. So think about this. i9 is the highest end. i7 is a step below. i5 is a step below. And i3 is a step below. Let's start with kind of a simple medium quality build, or I guess medium spec build. So let's start with this right here. This, I think everyone sees the same CPUs, right? They don't like randomize this or anything. Everyone sees an i5. So let's go ahead and choose the i5. And let's talk about some of these details, okay? After you've chosen the CPU, you've done all your research, you know how much you want to spend, you know how fast it is, all that stuff. There's this thing here called the socket. Now, in the past, I've noticed people get confused about the socket. The socket is actually, let me see if I can get a picture here. Let's say Intel CPU socket. A CPU has a bunch of little pins. Okay, not all CPUs these days, but let's keep life simple. They have a bunch of little pins, and then see all these holes right here? It's that simple. The socket type is literally just how these are spaced out. And what they've done over the years is they've kind of arranged these physically so that they're not compatible with each other. Not arbitrarily. It's like they kind of want to make sure that like you don't accidentally put an incompatible CPU in that motherboard. Does that make sense? So that's kind of their guarantee that if it fits in there, it's going to be compatible. I'm sure there might be exceptions. You might be able to bend a pin and make something fit. But in general, that's sort of their guarantee, is that it's an actual socket, and then you place the CPU in there, and if it fits, you're generally okay. A lot of these things are actually more complicated than I just kind of try to do the simplified version, but that's essentially it. So what's the socket type here? LGA 1151. By the way, these socket types between AMD and Intel are not compatible. So there's no such thing as an LGA 1151 for AMD. So what I usually like to do is, okay, this is the processor I know I want, so we can go ahead and add to cart. And what I'll do is I'll keep a little notes sheet and said, okay, my socket type is going to be an LGA 1151. Typically what I do is right after I choose the CPU, then I'll choose the motherboard. So let's go back to components and let's look at motherboards. And notice, like I said before, AMD and Intel-based motherboards aren't compatible. One thing to note is that AMD and Intel don't actually make the motherboards. Other companies do. What AMD and Intel do is they provide like technical information on how to make the motherboard and a bunch of specifications, but you'll see they don't actually generally make motherboards. It's these third-party companies. So we chose an we chose an Intel chip. So now we need to go to an Intel motherboard. And because we know no other socket type is going to be compatible, and notice that this was very specific. It said 300 series. Let's go ahead and choose that. So under CPU socket type, LGA 1151 300 series, and now we're only going to see compatible motherboards. Now you'll see that these motherboard prices vary by a lot. You'll see here we see as cheap as 70 up into the 200s. It wouldn't surprise me if some of these are 300. Yeah, we have 300. Now you might ask, what's the difference between these? Generally it's little features, like does it have onboard Wi-Fi? Does it have a very high-end Wi-Fi chip that's guaranteed to be low latency? The number of RAM slots, the number of M.2 slots. So that's generally the difference. And what you'll have to do, we're not going to spend much time on it today, but what often I like to do is, let's say for example, MSI. MSI is a pretty decent company, so let's choose this third motherboard here, MSI. Newegg's pretty good about this. These are all variants of this same motherboard, okay? And so this version might have less than or more than these other versions. So what you can do is you can click through. The core base motherboard is essentially the same. They'll use the same thing called the chipset, but they'll have different variants. Like again, the quality of the Wi-Fi, if they have Wi-Fi at all, the number of slots, those sorts of things. If they have any sort of, sometimes they'll actually have cooling mechanisms and so forth. The RAM speeds they support. But there's a couple of things that we have to note. So let's scroll down to the specifications. So main thing that we already talked about. So again, I'm on this motherboard. This MSI motherboard. We already noted the socket type, so great, we know that's going to be compatible. Don't worry about this chipset thing, but some of you that are a little bit more advanced, you might understand what this is. The chipset, I don't want to burn through class time talking about it. But this is important, okay? This means that, so RAM, so this is what RAM looks like. It's got a bunch of chips, and then it's got connectors, and you actually put it into a slot. Okay, so going back up to this picture here, if I can get a good picture. This one isn't super great at it, but these are actually slots. So what you do is you take these RAM modules, and you'll put them into these slots. So what that means is I can only put 4 modules in here. Okay, which generally is enough. Some motherboards come with more. Some of the lower end motherboards will come with 2. 4 seems to be a pretty good amount. But again, some of this stuff where they're trying to cut costs, like if you get a Dell or HP system, sometimes they'll just include 2 RAM slots. The thing that we care about is these RAM speeds. Okay, everything these days is pretty much DDR4, so you don't have to worry about that too much. But what we want to do here is capture this. Okay, so I'm going to put this here. This is basically, we don't need all of them. Really, we only need the range. So basically the range is from the slowest is going to be 2100 up to 4400. Okay, so there are other things, but here's the other thing. So we're going to, let's say, for example, we're going to put a solid state drive in here. This is this M.2. This is our storage interface. And again, it has a bunch of stuff, but what we care about, see these numbers right here? So SSD stands for solid state drive. Here's the compatible numbers for that as well. Okay, so this is the RAM speeds, and this is going to be the solid state drives that are compatible. Okay, and that's good enough for a simple system. Let's not get overly complicated. So we'll add that to the cart. Still going. Okay, so if we view our cart at this point, all we have is our CPU, which was the LGA 1151 300 series socket. That motherboard matches. And now, from there, we know how fast our motherboard can handle RAM. So that's a good next step, is to go to components, memory, and then desktop memory. So again, I went to components, memory, desktop memory. Now, what I could do, so I can purchase RAM within this range. That's the range of my RAM. So I can purchase the slow RAM, but it'd be kind of silly of me because I'm paying for the motherboard that supports much more, and it's just kind of like, why buy such an expensive motherboard? So we want to kind of gear, it doesn't have to be this exactly, but we want to kind of get close to this. So 4400. So it's pretty much all RAM these days is going to be DDR4 for the desktop systems that you build anyway. So let's filter that out. And so we said up to 4400. So let's say 4400 and a couple of them that are a little bit slower. That's probably a good stuff. Just a few of them, just so we have a little bit of range. Again, it doesn't have, but you're kind of, if you get very slow RAM with a very high-end motherboard, you're just kind of wasting money. At that point, you'd go back and change your motherboard. So I'm under RAM speed. And then I went through the different RAM speeds. Click apply. Now again, because you might be seeing slightly different search results, what I'm just going to do is I'm going to pick the first one that's, this one seems pretty decent enough. 4,000. 4,000 is close enough. It's only $100. That's fine. So I'll click that and then add that to cart. Your RAM doesn't have to match exactly. Just choose something that's compatible. I don't want to burn through too much class time getting into kind of mundane details. And so now at this point, we're kind of making some progress. We've got our motherboard, our CPU, and our RAM. And as I already mentioned, the next thing we need is storage. When I turn off the computer, I don't want all my Word documents to go away. So let's go over to computer systems. I'm sorry, components. And then we're concerned about storage devices. We'll talk about the difference between a hard drive and an SSD later, but for now let's just say SSD, internal SSD. So again, I went to components. In the middle here we have storage devices, SSDs, internal SSDs. And notice here, remember those numbers from before? We can say, okay, we'll just pick the first, just to save a little bit of time, we'll just pick this one right here. I'm sorry, yeah, so this one, it tells you how many products. This one seems to have the most, so let's go ahead and click that. And it's compatible, 2280. 2280 is compatible. And again, I don't want to spend too much time on this. Samsung's a very popular brand for solid state drives. So the companies that you'll see come up over and over again, Samsung is by far the most popular. They've historically made very good, reliable solid state drives. In the early days of solid state drives, they weren't actually terribly reliable. They would break down a lot. You'd lose data. They had all kinds of problems. And Samsung and Intel were pretty much the first two companies to actually make reliable, in my opinion anyway, reliable solid state drives that I could put in my computer and know that the data is going to magically go missing. But other companies have caught up a little bit, so you'll see Western Digital and Crucial and some of these other companies, but I tend to stick to either Samsung or Intel, and in this case, let's just pick Samsung. So I've got my motherboard, I've got my CPU, motherboard and CPU are compatible. I've got my RAM and motherboard are compatible. And I just picked my solid state drive, and my solid state drive and motherboard are compatible. Now again, like I said, if I try to power this thing on, nothing's going to happen because I need a power supply. So let's go to components. Power supplies. So I don't want to get into too much detail into the power supplies. PC Part Picker is actually really good at this, but power supplies tend to be rated by how many watts they can handle. And PC Part Picker actually tells you how many watts you need, so it's kind of cool. We're going to go to that site next. But for now, let's just pick the first compatible power supply. You can see here it says, okay, it's 550 watts. That's fine. Corsair is a decent brand for power supplies. And then finally, you can pick a case. I'm not going to really get into that, but you could say, I don't even see it listed here, but I'll just click this case. That's fine. There's different what are called form factors. Anything ATX related is going to be fine. There are some other specialty form factors. There's one called Mini ITX, but this is very surface level. You'll get some more of these details when you take like A+, okay? And that's pretty much it. You can get other detail-oriented things, like if you want to put a video card in it, if you want to get some other accessories, but these things are pretty much the base of what, if I were to order these things and then plug in my own keyboard and mouse into my monitor, I could actually have a working computer. Okay, so again, the basic order was, where's my CPU? Okay, the very first thing that you pick is your CPU. The main two companies that do CPUs are AMD and Intel. They're not compatible with each other. And their basic product line is with Intel, it's i3, i5, i7, i9, and they break it up into generations. Probably a little bit more complicated than I want to get into right now, but every couple of years they release a new generation. AMD has something similar, so they'll have, like right now their product line is called the Ryzen, and they'll have like the Ryzen 3300, 3500, 3700, 3900, same basic deal. The idea is as you go up, they get more powerful. And then I had to make note of the socket type. Then from there, I went and looked at some motherboards. Some manufacturers of motherboards are MSI, Gigabyte, Asus, probably many, many others I'm forgetting, but those are just a few of the more popular motherboard manufacturers. And then from there, I made a couple of notes, because remember I had to put RAM. I had to put RAM, which is my computer's memory, and I had to put a storage device, so either a solid state drive or a hard drive. In this case, I chose a solid state drive. And then I had to make notes of compatibility. Okay, and I wrote those down here. And then we went into the searching for RAM, and then we picked RAM that says, okay, this RAM speed is 4000. It's within the range of acceptable memory speed for my motherboard. Perfect. And actually, I've actually gotten burned by getting a motherboard that, say, is 4400 and buying RAM speed 4400, and it was kind of flaky. So what I actually like to do is just kind of, whatever the motherboard claims, is to just go a little bit slower, just to guarantee that it's going to be okay. So we got compatible RAM. We got a compatible solid state drive. Again, some of the manufacturers are Samsung and Intel, Western Digital, but I tend to stick to Samsung or Intel myself. We grabbed a power supply. The power supply has to have a high enough wattage to be able to power everything. We'll get into those power calculations later. You don't have to manually do them. They have sites that do it for you. And then a case, and this is just an ATX mid-size case, which should be able to handle everything. Now I glossed over a lot of things because if creating PCs were that easy, everyone would do that. There's a lot of considerations. You want what's called the balanced system. You don't want what's called a bottleneck. Has anybody heard the term bottleneck before? So, in your own words, how would you describe a bottleneck?
One component is more powerful than the other.
Exactly. So, the way it works is that your hard drive feeds data to your computer's RAM. Your RAM feeds data to the CPU. The idea of a bottleneck is that you've got one of them that's much faster and much slower, and it can't feed it into an efficient manner. So what I mean by that is imagine if you had a really, really fast CPU, really, 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 really fast RAM, and really, really slow hard drive. Like this thing is just crawling slow. What's gonna happen to the CPU? Is the CPU going to be able to do number crunching all day? No, it's just going to sit there waiting for data most of the time. That's what we call a bottleneck, is that you've got some part of the system that's much slower that can't actually it's holding up the rest of the system. You have to consider those sorts of things. You kind of want a balanced system, so you don't want, a really, really fast hard drive and a really, really slow CPU. You kind of want to balance it out so you don't run into bottleneck issues. And we didn't really have time to get into that. There's also issues of do these things actually all physically fit together? I've had instances in the past where I got some high-end RAM that actually required its own cooler, its own fan, and it bumped up against my CPU fan so that the two didn't physically fit together. There's just so many of these different considerations that for the average person it's just too much. It's just a lot of work, and that's why a lot of people don't. So there's a site that's very useful that does take in consideration a lot of those things. Has anybody heard of the site PC Part Picker before? Show of hands, how many people have heard of it? Okay. So and let's just go to it. So PC Part Picker. What this site does is with Newegg, everything was very free form. I had to know what I wanted. I had to do compatibility myself. I had to do all that stuff myself. What PC Part Picker does is they don't actually sell anything. What they do is provide like a wizard where you go through and you go through one component at a time, and it gives you warnings along the way if it thinks that something might be incompatible or unbalanced. And then from there, what they do is they give you links to the big companies like Amazon, Newegg, Best Buy, where you can buy each one of those components for the best price. I'm sure they get a little reference fee or something like that. That's how I guess they make their money. Okay, so let's go to, so is everyone at this site, PC Part Picker? Let's go to System Builder. Now, in Newegg, we built an Intel system. I want you to get used to maybe some of the things related to AMD. And you can see this, they listed out basically the order that we chose things. We chose a CPU. Our CPU happened to have a fan, a CPU cooler built in with it, so we didn't have to choose a separate one. Then we chose the motherboard, we chose the memory, and then we chose the storage. We didn't need a video card, and then we chose the case and power supply. And then some of these other things, these are the details that you don't always need. But let's choose a CPU. This CPU right here is pretty popular right now. It's a mid-level CPU, the Ryzen 5, remember? We have the Ryzen 3, Ryzen 5, Ryzen 7. I think before when I told you the names of these, I think I messed it up a little bit. But it's similar to the i3, i5, i7, i9. So we have a Ryzen 5, Ryzen 7, Ryzen 9. And then this right here, this 3600, this 3 just means that it's the third generation of this architecture. But really the part that you just care about is the Ryzen 3, 5, 7. So Ryzen 5, that's pretty middle of the road. That's good. It tells us some information, but it keeps, it just keeps it very high level where, excuse me, on Newegg, they were very, very detailed about the specifications. Here they just tell you kind of the main things: how many cores it is, the CPU speed, how many watts it uses, whether it has onboard graphics, and whether it uses something called SMT, which we'll talk about later. So very, very high level information. Let's go ahead and add this. This is a pretty decent CPU. Now this CPU actually will have its own built-in CPU cooler, so we don't need to purchase a separate one. Some people, if you're doing overclocking or other things, sometimes people will purchase a separate CPU cooler. In this case, to keep life simple, let's just use the built-in one. Motherboard. And what's nice here is it's going to basically give us compatible motherboards. We don't have to worry too much about things. Okay. Again, it gives us high-level things like how many memory slots and how much memory it supports. MSI is a good brand. I've used them before. We'll go with this. And again, it's nice because it will only list RAM that's compatible with that motherboard. So we can be reasonably certain that if we choose this memory module here, that will be okay. 3200 is a pretty decent speed. It's kind of somewhere in the middle. So we'll click add. Storage. Let's just do, I don't know if there's a check mark. Well, before we did a solid state drive, let's do a regular hard drive. The difference between the two is one is it doesn't have any moving mechanical components. With a regular hard drive, it actually uses a magnetic spinning platter, and it reads, I like to think of it kind of like as a record player, and it actually reads bits off that magnetic spinning platter. But this is a decent drive right here. This one right here, the Caviar Blue. So we'll go ahead and choose that. Now, remember what I talked about before? That when we choose our power supply, the amount of watts it uses needs to be above. And usually you don't want to, like, say this is 169. You don't want to be right on the edge and get like a 200 watts power supply. Usually I like to go, I like to have a little bit of breathing room with it. One of the things is that if you're always taxing that power supply, it might not last as long. It might have issues over time. So I usually like to buy a little bit higher of a power supply. But let's do power supply before case. We're not going to do a video card. We'll just assume the motherboard has it built in. So let's say power supply. Now, some of these are kind of high-end for what we need. There is kind of a low point where, for home systems, they don't really go lower than that. So you'll notice that about 500, 450, that's about as low as you'll see on this site. Now, if you were to open up these computers in here, it wouldn't surprise me if we saw like a 300-watt power supply. Again, when you're manufacturing things, tens of thousands of units at a time, what they do is they try to save every penny they can. But for us, it might be this 600 watts of power supply is only $60. At some point, you're just saving like $5 or $10 at a time. For one system, it's not that big of a deal. 500 watts to me is pretty decent. So just choose any of these. But I'm going to say this one's fine, I guess. Now they do have power efficiency ratings like bronze and silver and gold and stuff. I don't want to get into that. It's maybe a little bit detailed for what I want to do in this class. And then, very quickly, like we did before, you can choose a case. First case is fine. Now that's pretty much it. I think, and then they have their little link where you can get all the individual components. And we're not going to build computers in here. That's more like your A+ class. But yeah, that's pretty much it. So that's the first assignment I like to do, is just to, again, like I mentioned, the book talks about things very generically, like the idea of a CPU or the idea of RAM or the idea of a hard drive. I like to get into concrete things and actually go to a site and say, here's the brands, here's the typical speeds you're going to be working with, here's the different considerations. Okay. Now let's do this. Now that we've got a system, let's go back into Newegg. Actually, I think we might just be able to click these individually. Does it tell me the specs? No, it doesn't. Or no, it does over here. Okay. So let's kind of do that process that we did before, but in reverse. Remember, before we would go through each component and say, okay, this is the CPU I have. That means it supports these motherboards. Let's do the same thing, but we already know all of our products. Now we're just kind of more doing like a compatibility check, okay? So I'm going to clear this out. So we started off with our CPU. So what I'm going to do is click my CPU. This is more like double checking PC part picker's work. And I scroll down here. I'd imagine they have the socket type here somewhere, hopefully. Yeah. So what's the socket type here? AM4. So that means that whatever motherboard it decided to choose needs to be AM4 compatible. So now we go to our motherboard. So question, yes or no, is this a compatible motherboard with that CPU? Yes, why? Because it's, what socket type is it? AM4. The reason I'm asking you these questions is because this is actually part of your assignment, is that you have to go back and after PC Part Picker and go back and state all the compatibility things that PC Part Picker did for you. Okay, perfect. Let's go to the computer's memory. And we already can see it right here. So the speed is 3200. If we go back to that motherboard, I might call it memory speed. The supported speeds is 3200 on that list of supported speeds. Yes, so perfect. We know that it's good. And it's kind of somewhere in the middle. It's not like we're buying very low ends. We could bump it up to maybe something a little bit higher because this motherboard supports more, but that's good enough. So it's somewhere in the middle. Now with the solid state drive, they have this M.2 form factor with these spinning hard drives. Essentially what you're looking for is this thing called the interface. So it's SATA 6 gigabits per second. And then we just need to make sure that the motherboard supports that. I'm oversimplifying some of these things because there are cases where you can use something that's out of spec. It'll just run slower. But at that point, you're kind of wasting money. So let's just make sure that it has SATA 6 gigabits per second, and it has 6 of those. So we're perfect on that. And then, so it's estimating that we're going to use 169 watts. We can see here we've got a power supply that's capable of 500 watts. We have plenty of room to work with. The reason I say, I mean, there's a couple reasons. You may want to add a video card later, and then video cards can actually take up several hundred watts just themselves. So that's a consideration. And the other thing is I don't like to run my power supplies at like the highest capable because they tend to wear out a little bit faster. And the cost savings isn't that much. For me to find a 300 watt power supply, I might save 10 or 15 bucks, which if you have a computer for 5 years, which is not that uncommon these days to have it for many, many years, what's another 10 or 15 bucks to get a little bit better of a power supply? Okay, so any questions on that process? Everyone's good with that? Again, I realize for some of you that it might be a little bit overwhelming if this is your first introduction to this stuff, but let's very quickly summarize the main things. CPU, socket type, memory RAM speeds. When it's an SSD, the M.2 form factor, so it'll be a number. If it's a hard disk drive, it'll have SATA something, let's say 6 gigabits per second or 3. Almost everything these days is going to be 6, so you just need to make sure that it has 6 gigabits per second. And then power supply. And then make sure whatever number that it gives you, the total power usage in watts, that the power supply can actually handle that. So those are the main things. And we're doing good on time. Rather than give more examples, what I think I want to do is go through the assignment and then give you a few minutes to start on the assignment. Okay, is everyone good on writing that down if you were going to write that down? Okay. So for your homework assignment, go to PC Part Picker. It doesn't have to be a Newegg. So go to PC Part Picker, and you're going to make 2 PCs. One's going to be kind of a middle of the road, like we just built. So like an i5 or a Ryzen 5. Ryzen 3 or Ryzen 5, i3 or i5. Medium RAM. Actually, I have these backwards. The first one's the high-end PC. Let's start with that. So the first PC would be a very high-end CPU, like an i7 or an i9. Probably a very expensive solid-state drive, very, very fast RAM. A lot of that fast RAM, say 32 gigabytes. And then copy and paste the link. So PC Part Picker gives you a link. I hope I didn't already close it. Did I? No, I kept it open. I think you do, it's like you do save or so. Oh no, right here. So in your assignment, what you'll do is you'll give me, I'll walk you through it, but when I say give me the link, this is what you'll do. And then something down the middle. So maybe like an i3 or an i5 or a Ryzen 3 or Ryzen 5. Maybe 8 gigs of RAM. The RAM doesn't have to be that fast. So maybe something like even 2100. It doesn't have to be like 4000. Doesn't need that much RAM. 8 gigs is fine. A regular old hard drive is fine because the solid state drives get a little bit more expensive. And like I said, the power supplies, there's kind of a floor that at some point you're not really saving any more money. So like a 450 or 500 power supply should be enough. For this very high-end machine, you might have a 1,000-watt power supply, you know, if you start adding video cards and stuff like that. So you'll make 2 PCs. And again, I'm not looking for a whole lot because I realize this is your first class. But I do want, so you're going to do this inside of a Word document. So let's open up Word. And let me just take you through like an example. So what I would do is for my first system, I would copy and paste this link. This link. You know, and so on, okay? That's what I want to see. What I've had in the past is people just write to write. I don't like that because I don't really care about the number of words. I care about the information. And I know in many of your other classes, you'll have like a word minimum. To me, it just makes it longer for me to grade. So if you can fit what you need to fit in just a few sentences, like just say a short paragraph, that's perfectly fine for me. Sometimes what I'll see is people get into way too much detail without actually telling me the things I care about. The things I care about is the socket type compatible, Are the RAM speeds compatible? Is the M.2 form factor, is that compatible? And that's the main thing I want in that little paragraph, is just telling me that the components are compatible. And then you do the same thing for another system, is you'd build it out on PC Part Picker. I think there's like a clear start new. And then what you do is you start a new, and then once you're done, you do the link, and then the same thing for the second one, okay? Any questions? So we have about 10 minutes. What I want to do is go ahead and get started on that in case any of you need some help with it. So this class is till 10:45. Go ahead and just get started on it, and then just raise your hand if you have any questions, okay? So I'll shut up now, and I'll let you work on that.